Exploring a 3D scene with a conventional pinhole camera limits the user to regions of the scene to which there is direct line of sight. We propose scene exploration using a graph camera constructed to sample multiple scene regions simultaneously. Here the graph camera rays that hit the door portal are bent to capture a better view of the adjacent room. As the user approaches the portal, the graph camera morphs into a pinhole for a smooth transition into the adjacent room. Here the graph camera is constructed to shrink the occlusion shadow of the clock store. The graph camera rays reach around the occluder to sample scene regions hidden in the pinhole image. As the user changes the view, the graph camera model is updated to track the occluder. Consider the case of street-level navigation in a city scene. The current user position is marked by the red quad. A conventional image does not sample the side streets. A portal-based graph camera would not be effective in this case either, since the portals have a small screen footprint. We have developed a maze-based graph camera constructor that distributes the rays reaching the intersection to each of the right, forward, and left outgoing street segments. The resulting raw graph camera image samples the left and right street segments well. A similar graph camera is constructed to sample behind the user. Finally, the raw graph camera images are mapped to a display surface. The left panel shows behind and the right panel in front of the user. The resulting graph camera image captures the current street segment as well as the street segments beyond the first intersections. The user can change the ray split ratios interactively to emphasize different scene regions. The third-person view shows the current user position with the red quad. Objects are rendered transparently as they cross the user quad. When the user reaches an intersection, a turn is executed automatically in 4 steps. First, the left and right perspectives of the back panel are retracted. Then, 2 of the front panel perspectives are retracted in favor of the perspective chosen for the turn. Then the back view turns. Finally, the lateral perspectives are deployed again and navigation proceeds on the new street segment. Another application of the graph camera is 3D scene summarization. Here the user constructs a graph camera interactively to capture the facades of most buildings in the scene. The resulting graph camera provides comprehensive sampling and good control of image space use, which is challenging for conventional scene summarization techniques. Here the graph camera samples both floors of the house by compressing the stairs. Summarization images can also be rendered with maze-based graph cameras. Here the graph camera rays start at O and sample the 2 rooms of the bakery as well as outside. A real-world graph camera is implemented with a video camera for each frustum. Here a graph camera integrates 3 video feeds. One challenge is the implementation of near and far clipping planes connecting the graph camera frusta. We implement clipping planes by background subtraction. The subject is automatically erased from all video feeds except for the one where the subject is located. Here the subject is located in the right frustum, and he is erased from the video feed for the left frustum. Pixels taken from the background images are of course not live, and they are marked as uncertain using a red highlight. In this example, the graph camera integrates 4 video feeds. The user can zoom in to leverage the full resolution of video feeds of distant frusta. We have explored the advantages of the graph camera in the context of 3D scene exploration, 3D scene summarization, and comprehensive real-world scene visualization.